Hi everyone. In this part we will focus on the points where the functions are not differentiable. A function can fail to be differentiable at a point in a number of ways. So we will see that, but before this let's look at this example. Derivative of absolute value of x at the point 0. Does it exist or not? Let me use the formal definition of derivative and check the function. Derivative of f at the point 0 is equal to, this is formal definition, limit definition of derivative, f of x0 plus h, which is f of 0 plus h minus f of 0 divided by h. Since the function is absolute value of x, we have absolute value of 0 plus h minus absolute value of 0 divided by h, and this is the limit problem. I actually solved this problem before when we had the lecture of limit, when we had the topic of limit. So we have to look at this limit from left and right. Okay, when we approach to the point 0 from left, absolute value of h becomes h divided by h, which is 1. When we approach to the point 0 from left, then it means absolute value of h is minus h divided by h, which is minus 1. As you see, these two limits are different, they are not equal to each other. This is why this function does not have a limit at the point 0. Since the limits does not exist, the function does not have derivative at the point 0. So let's geometrically examine this function. As you know, the graph of absolute value of x is this. So let me write down absolute value of x as a piecewise function. When x is positive or equal to 0, this is x. When x is negative, we have minus x. So this is positive part of the graph and this is negative part of the graph, minus x. Okay, so this is the graph of absolute value of x. When we differentiate this function, we have 1 when x is 0 or greater than 0, we have minus 1 when x is negative. So as you see, derivative from left and right is not equal to each other. This is why the derivative does not exist at the point 0 for the absolute value function, and it is the graph of derivative of absolute value function, 1, 1 and minus 1, 1 and minus 1. What about the point 0? The fact that f prime of 0 does not exist is reflected geometrically in the fact that the curve absolute value of x does not have a tangent line at the point 0, 0. Another example, the graph of f of x is given below. Find the region where the function is positive but its derivative negative. Its derivative is negative. The function is positive means it must be above the x-axis. Something like this, maybe this part, okay? And this part is above the x-axis. If it's negative, it's below the x-axis. F prime is negative means the function is decreasing on the given interval. So let's look at this part now. The function is positive at this point, from here to here, okay, and the function is decreasing on the given interval from this point to this point. So on this interval f is positive but its derivative is negative. It's all. One simple question. The tangent line to the graph of f at the point 2, 3 passes through the point 6, 7. Then find derivative of f at the point 2. Let's suppose that the graph of f is something like this. Okay, it does not matter. It's an arbitrary graph, and this is the point 2, 3. So the tangent line at this point is given by the red line, and the other point is 7, 8, which is given in the question. So f prime of 2 means delta y divided by delta x. Delta y is the difference in the y-axis, which is 6 minus 3. Delta x means difference in x-axis, which is 7 minus 2. It's all. It's 5. So 3 over 5 is derivative of that function at the point 2. So the crucial question: what are the points where functions are not differentiable? A function can fail to be, as I told you, to be differentiable at a point in a number of ways. The first way is one-sided derivative. The function f is differentiable on closed interval ab if it is differentiable on open interval ab. And if right and left derivative is equal to each other, then we say that the limit exists and derivative exists also. But if you have sharp corners like this, then we say that one-sided derivatives can be different at a point. It means that the function does not has derivative. Okay. Let me give an example to understand this. Let's have this piecewise function x squared for negative and 0 values, this is x squared, and 2x for positive values of x, and the derivative of f at the point 0 from left is equal to limit when h tends to 0 from left. It is the formal definition of derivative f of 0 plus h minus f of 0, since we are looking derivative at the point 0, is equal to limit when h tends to 0 from left, h squared minus 0 squared divided by h, this is equal to 0. So derivative from left at the point 0 is 0. What about derivative from right? Again, the limit formula of derivative gives us that. I again use this formula. So we have 2h minus 0 divided by h, and it's equal to 2. As you see, left derivative is equal to 0, right derivative is equal to 2. This is why derivative does not exist at the point 0. Okay? What about this question? Is this function differentiable at the point 1? Let me slightly change the function. Let's say this is 1 and this is also 1. Okay? So, let me slightly change the function. So this is, I will directly write down the formal definition. I will directly use the formal definition of derivative and see what's happening. Okay, this is 1, this is 1, this is, let me clear also this one, this is 1, this is 1, from left, from right. Okay, So 1 plus h square minus 1 square divided by h. Okay, since it is the point 1, this is equal to limit when h tends to 0 from not 0. This is 0, of course. I am very sorry. It is 0. It's coming from definition of derivative. 2h plus h square. Okay, if you expand this formula, you will have 2h plus h squared divided by h, and if you cancel all these h's, you will have 2. What about this one? We have 2, the parentheses of 2, 1 plus h minus 1 square divided by h. How do we get 1 plus h here? 2 times 1 plus h is coming from the definition of function. Do not forget the function. And this is equal to limit when h tends to 0 from right 1 plus 2h. If you simplify this expression, you will have 1 plus 2h divided by h. When h tends to 0 from right, you have infinity. Okay, again, the function is not differentiable at the point 1.